Hello, this is Captain Chaudhari. I was doing these videos on basic stability calculations which would help the pre-C and a second mate candidate. Now here today I want to talk about a numerical which deals with list, which deals with free surface effect, and which also deals with kg by moments. We are going to shift some weight, we are going to create some free surface effect, and then we are going to find out what is the list. So here is the numerical. It says that there is a ship of displacement 22,000 tons, kg 7.8 meters and km 9 meters is upright with no free surface moment. Port deep tank, that is a length 15 meters, breadth 12 meters, is 7 meters deep. Half the ballast water, that is 1.025 density, is shifted to starboard deep tank from here to here, which is identical. What is the list? What is the final list? It seems with this tank full of ballast water, density 1.025, the ship is upright, which means that when half of this water is shifted to the starboard tank, we are going to have free surface effect from both the tanks, and we are going to have list because we are shifting the weight. Now the thing is, how much is the weight shifted and what is the change of kg? We are going to find out. Now one way of assuming or one way of doing the calculations is as if this 50% block of salt water, that is the ballast water, is pumped out of the ship, and the same amount of, that is the block of ballast water, is loaded in this tank. That is one way of thinking of it. So in kg by moment calculation, in one step we are going to pump out this liquid, and in another step we are going to load the water here. But now let us say if we say this half the block, instead of pumping out, is directly shifted here, then what happens? Now the height of this block is 3.5 meters, because half of 7 meters, 7 meters is the height, 3.5 meters. So center of gravity of this block, the centroid of this block, is half of 3.5. That means 1.75 meters from top and 1.75 meters from this demarcation. Now if this block is shifted over here and it gets transferred over here, if we assume that the block is transferred over here, then can we say that the total vertical shift of the centroid of the blocks is 3.5 meters. So we say that this particular block, which is occupying the 50% of the deep tank, let us see what is the weight of this block. So it is 15 meters into 12 into 3.5 into 1.025. The mass of the block is 645.75 tons. 645.75 tons. So this 50% of the block which is shifted weighs 15 into 12 into 3.5. This is the volume multiplied by 1.025, that is 645.75 tons. Now it is vertically shifted downwards, so it's going to improve the kg. So let us do the kg by moment calculations. The normal calculation: weights, ton, kg. Kg of the ship is 7.8 meters. The displacement is 22,000 tons. Vertical moments in tons meter. The port listing moment and starboard listing moment are initially nil because the vessel is upright. Now this 22 into 7.8 gives me the vertical moments as 171,600 tons meter. Now what we are saying is we are shifting a certain weight. Now I put plus here there is plus over here also. But when we talk about the shifting, we do not put any sign here, so I put 0 sign here. But the weight is 645.75. Now because this weight is shifted vertically downwards, we are shifting the weight towards the keel, so vertical moments will be reduced. So I put a minus sign here, and this 645.75 is multiplied with 3.5 gives me 2260.1. 2260.1. And the vertical downward shift is 3.5 meters, right? So what is the new vertical moments? Gives me 169,339.9. Now over here we still have the same weight, 22,000 tons, and let us see what is the new kg. New kg is 7.697. 7.697. So we assume that for the small change, or basically there is no change of displacement, the km remains same. So km is 9 meters. So what is the GM? GM is 1.669, or I can say 1.670. 1.670 meters is the GM, but it is GM solid. Now let us say we have shifted a weight sideways. This distance from here to here is 12 meters, so from here to here is 6 meters. So from centroid to centroid the shift will be 12 meters. We are shifting the liquid from port side to starboard side. It is going to cause starboard listing moment, and starboard listing moment is going to be 645.75 multiplied by 12. 645.75 into 12 gives me 7749. 7749 is the starboard listing moment. This is the starboard listing moment. Now we still have the same formula as I told you, and the formula is listing moment is nothing but delta GM tan theta. Now we have the GM here, but we don't have free surface correction yet found. So what is the free surface correction? If we look at this tank, the plan view of the tank would be like this, and here is the centroid. If we look at this tank from top and this tank from top, both they would look like this. The breadth being 12 meters, the length being 15 meters, and the free surface moment that is caused by these tanks, each tank will be length into B cube upon 12 multiplied by density of the liquid which is inside. So it is 15 into 12 cube upon 12 multiplied by 1.025. This is the free surface moment for one tank, and for the two tanks the free surface moment would be multiplied by 2. So let me do the calculation. 12 square is 144 into 15 into 1.025 equals into 2 gives me 4428. 4428 tons meter. And this divided by the displacement divided by 22,000 gives me the free surface correction as 0.201. Free surface correction is free surface movement divided by displacement gives me 0.201. And GM solid minus free surface correction will give me GM fluid 1.67 minus 0.201 gives me 1.469. So GM fluid is equal to 1.469. When we apply these values in this formula, we get tan theta is equal to listing moment divided by delta GM fluid. So that is 7749 divided by 22,000 into 1.469. So 7749 divided by 1.4 gives me list as 13.48 degrees. So this kind of list would be obtained. The point to be noted here is the GM is low and there is a large listing moment that is caused because we are shifting a weight like 645.75 tons through a distance of 12 miles.